Hello and welcome to Naima JPS Maths video, Year 4, Angles 2. In today's lesson we're going to think about how our knowledge of angles can help us to work out missing angles. So first of all, let's just review our knowledge of angles. How many degrees are there along a straight line? Hopefully you said 180. Let's just use our protractor to check this. So I'm going to line up the protractor along the straight line. If we have a look from the 0 all the way round, is 180 degrees. Okay. How many degrees if you add up all the angles in a triangle? Again, hopefully you said 180 degrees because it's the same. Let's just use our protractor just to check this. So if I do this angle first. Now we need to be very careful when we're reading our protractor of which one of these two numbers it is. Now I can see that this is going to be slightly bigger than a right angle, which tells me it's going to be 100 degrees, not 80. But also if you follow it starting from the 0 from this side all the way around, then I can see clearly that it's the bottom scale of numbers, so 100 degrees. So we've got 100 there. Then this angle over here, it is roughly 40. So we've got 140 so far. And then this final angle is again 40, so 180 in total. Okay, how many degrees are there in a circle? Hopefully you've said 360. Now let's use the protractor just to help us to see this. Now I've drawn a dot over here to help us to place it to see that it's going round from the same spot. So I'm starting off with the protractor facing upwards. And if you look carefully, if you're going round from 0 all the way to 180 and all the way around again, if it was a full protractor, 180 add 180 is 360. And if I spin the protractor, you should be able to see that. Here's it going round half a turn and then going round another half a turn. So a full turn is 360. Okay, so we're going to use this knowledge to help us to answer some questions. Now we don't need the protractor because we're going to just use our knowledge to help us. So first of all, here is a straight line, and I've drawn one line up so that we've got two angles, this obtuse angle and this acute angle, and the acute angle is 47 degrees. So using this knowledge we should be able to work out what the obtuse angle is. How do you think we can do that? Now hopefully you have realised that because we know that along a straight line it's 180 degrees, if we take away 47 degrees it will leave us with this angle. Okay, so 180 take away 47 is 133, so this angle here is 133 degrees. Okay, on to the next one, slightly harder. Okay, how do you think we could work out this one? Okay, hopefully you have said that if we, because we know again that along a straight line there's 180 degrees, if we add this angle, 16 degrees, to this angle, 41 degrees, so we get 57 degrees, then we just take away 57 from 180 and it will give us this angle. So 57 away from 180 is 123, so this angle here is 123. And if we want to just sort of check in our mind whether we think that's roughly correct, I can see that this angle is definitely bigger than a right angle, but not hugely bigger, and so 123 does make sense. Okay, on to the next one. Right, how do you think we could work this one out? Remember, this time it's not along a straight line. Okay, so on this one, it's around a point, so it's as if it is a circle. Okay, so we're working with the total should be 360 degrees. So if we add up these 110, 48 and 59 and then take it away from 360, we will have this angle here, which would be 143. So again, we can use our knowledge to think, does that sound about right? A straight line would be along there, 180, and this is a bit smaller than that. Okay, it's between a right angle and 180, so 143 would make sense. Okay, so this angle here is 143 degrees. Okay, on to the next one. Have a think how you could work this one out. It's a bit more tricky. Okay, so you may or may not have seen that this angle here is the same as this angle down here. Okay, the opposite angle is the same, and it's the same here. The opposite angle is the same as this one. Okay, it's the way that the lines have been placed. So because we know that this one is 45 degrees, we know that this one down here also is 45 degrees, so equaling 90 degrees. Now it's round a point, so we know the total has to be 360. Okay, so the total is 360 and these two are 90. So if we do 360 take away 90, we get 270. So the total of these two here is 270. Now we want to know what each one is. So obviously we have to halve 270 because they're both exactly the same. 270 halved is 135. So each of these two angles is 135 degrees each. Okay, the next thing I'd like to do is to review your knowledge on triangles, because we need to make sure that we are confident in properties of triangles before we go on to the next part. So let's name all of the triangles. First of all, this is an equilateral triangle. Of course, an equilateral triangle, as the name suggests, all the sides and all the angles are equal. Okay, so if we wanted to work out what one of the angles was, what sum do you think you would have to do? Now hopefully you have suggested, because we know that all the angles add up to 180, that because each angle is equal, you would do 180 divided by 3. So each angle in an equilateral triangle is always going to be 60 degrees, in whatever equilateral triangle it is. Okay, what's the name of this triangle? It's an isosceles triangle. So in an isosceles triangle, these two of the angles have to be the same, and two of the sides have to be the same length. So these two angles in this isosceles triangle are the same, and the two sides here are the same. What's the name of this triangle? It's a scalene triangle. So in a scalene triangle, none of the sides are the same length, and none of the angles are the same size. They're all different. Now you can have a right angle triangle. Okay, and a right angle triangle can either be an isosceles right angle triangle or a scalene right angle triangle. But obviously you can't have an equilateral right angle triangle. It just doesn't exist. Okay, so we're going to use our knowledge of triangles and of angles to help us in the next questions. Okay, so in this question, we have a right-angled scalene triangle. Okay, so none of the sides are the same length and none of the angles are the same. See if you can explain how you would work out this angle over here. How would you work this angle out? Okay, so you should know that if we have this sign here where it's sort of boxed the corner in, it means that it is a right angle. Okay, so a right angle of course is 90 degrees. We have this angle which is 35 degrees, so we can add them together. We have 125 degrees. We know that in total there should be 180 degrees, and so we take this away, the 125 from 180, which will give us the final angle, which is 55 degrees. Right, the last question. So in this one we have an isosceles triangle, and we know that these two sides are equal because of these lines. These lines mean that the two sides are equal. So we have this angle up here. How do we work out what the angles down here are? See if you can explain. So because we know that this angle up here is 36 degrees, and we know that this is an isosceles triangle, we know that these two angles down here must be the same. Okay, they're the same in degrees. So what we need to do is, we know that the total is going to be 180. So we need to do 180 take away the 36. So 180 take away 36 is 144. So we know the total of these two angles down here is going to be 144 degrees. But we just want to know what they are, each of them are. And so we know that they're going to be equal, so we can just do 144 divided by 2. 144 divided by 2 is 72. So we know that each of these angles is going to be 72. Now obviously, if we had been given just one of these angles, and we knew it's 72, and we hadn't been given the one at the top, we could have worked it out by thinking, okay, I know if that one's 72, the other one must also be 72. You could have added them together to give you 144, and then you would have known that whatever was left from 180 take away 144 would give you the final angle up here, 36. So it's the way that you can work out any angle in an isosceles triangle. Okay, hopefully you found this video useful. Next I would like you to go and find the worksheet that I've given you to help you practice the skills that we have learnt. Look forward to finding out what you have done.